sure you're wondering what this video is about, and if you are and never looked at the title of the video, then let me be the first to tell you it's all about torque. But what is torque? Well, it's
Wait, Nick, how do you not know what torque is?
Hey, don't blame me, okay? I was too busy playing Angry Birds when Mama Donna went over torque, okay?
Oh, don't worry. I know what torque is. Here, let me explain.
Okay.
Are you going to explain it? So torque is a force that is rotational in nature. In other words, it's like a twist. It's the angular equivalent to a linear force, and we'll be using torque in many ways during this video.
Oh, so it's like a twist.
Nick, I literally just said that.
Oh, I get it now. It's like a twist, but how do you find it exactly?
You know, there's a formula for finding torque, right?
Oh yeah, I remember the formula for finding torque.
The formula for torque is actually one of the easier ones to remember. All you need to do is multiply force times the sine of the angle of the force, and then multiply those by the lever arm. If the force is applied perpendicular to the object, then the sine of the angle, which happens to be 90 degrees, is just 1. Wasn't that easy? Well, was it?
Oh yeah, I totally remember that.
Oh, so now that we know what torque is and how to find it, what do we say we, give torque a whirl, give it a spin, guys?
I have a great idea. Why don't we demonstrate a bridge problem?
Oh, a bridge problem? You mean like this?
No structure of steel and concrete can stand such a strain. Steel girders buckle and giant cables snap like puny threads. There it goes!
No, that's not at all what I... Why would you think that? Christian here will show you a bridge problem.
So here we have a bridge with a known weight of 10,000 newtons and length of 20 meters. We also know that there's 2 support beams on each end of the bridge. If a car with a known weight passed over the bridge, and we know how far onto the bridge the car is, we can find the force that a support beam exerts on the end of the bridge using torque equations. First, we must determine the amount of torque that is being exerted in the clockwise direction. This would be from the bridge itself and the car. Using the support beam on the left as our pivot point, therefore the torque that the left beam exerts is negligible. And using the equation for torque, we can see that the car has a lever arm of 7 meters from the pivot point and exerts a force of 20,000 newtons downwards. Using the equation, we see that the car exerts a torque of 140,000 newton per meters in the clockwise direction. Next, the bridge's center of mass, the middle of the bridge, has a lever arm of 10 meters from the pivot point and exerts a force of 10,000 newtons. We find that the bridge exerts a torque of 100,000 newton per meters in the clockwise direction. These two added together give the total amount of torque exerted in the clockwise direction. Next, the only torque exerted in the counterclockwise direction is the right support beam. We know the lever arm from the pivot point, 20 meters, but do not know the force it exerts on the bridge, and therefore, we will replace it with a variable, x. Knowing that the amount of torque exerted in the counterclockwise direction must equal the amount of torque exerted in the clockwise direction, we can solve for the force the right support beam exerts on the bridge.
That was a lot of fun. Not to mention, I learned so much about torque.
Yeah, me too. I learned what torque is, how to use it, and how to find it.
Oh, thank you guys for teaching me. I had a really great time and I enjoyed it.
Wow, that's just really great. I can't believe we had such a good time learning about torque.
Did somebody say torque?
Mrs. Hart!
I was wondering what you guys were up to, so I decided to come and see.
Isn't torque really cool?
Yeah, but I have one question. Can I have my chair back?
Oh, okay.